Hey guys, welcome back to the Hats YouTube channel. Today we'll be taking a look at the four SUVAT equations. Our first equation is v is equal to u plus at. In other words, final velocity is equal to initial velocity plus acceleration times time. This is a very logical equation. There's no real equations to derive, which derive into this, but rather it's just your intuition. Suppose you have initial speed of 5 meters per second, you have acceleration of 10 meters per second. It should really be squared here, but you know what, doesn't really matter. After the first second, you would have gained 10 meters per second to your initial velocity, making for a total of 15 meters per second. After 2 seconds, you would have gained 20 meters per second, and after 3 seconds, you would have gained 30 meters per second. And really, that's all this equation says. It just says, okay, let's take your initial velocity and let's just add in all the acceleration that would have happened over a specific period of time. And it should follow that when time is equal to 0, your velocity final is equal to your velocity initial. Your second equation is the only other fundamental equation. It says that 1 over 2 times u plus v times t is equal to your displacement. Now, what's really interesting here is the 1 over 2 times u plus v, because that's actually average velocity. The way we determine that is because when you look at this velocity time graph, and keep in mind these equations are only true under constant acceleration for this exact reason, you spend half the time, suppose you find a midpoint. The midpoint is always when time is half. You can also find the midpoint by taking the average of any 2 points which are equidistant from the midpoint. And it's very easy to do that with your start and final point, obviously. That's why we use them. And after you find this midpoint, you realize half the time you've gone at a slower velocity, and half the time you've gone at a faster velocity than average, right? So then we can just say, on average, you've just gone at half the at the average velocity, right? Because half the time you've gone slower, half the time you've gone faster than average, then the halves cancel out, and you've basically gone at average for that amount of time. And then it just follows, right? This equation is really saying average velocity times time is equal to displacement, and that's true. The third equation is just the combination of the first two here. So really, you're just isolating for t in both cases. You see I've already done that here. I've written the first one. I don't know why I didn't rewrite the second one. Doesn't really matter. But here, the first one rearranged, and using this, you can see how the second one was rearranged. You equate the 2 times, and that leads you to this final third equation. V squared is equal to u squared plus 2as. Okay. Now there's one more equation, which is built upon the first two again. That's why those are the fundamental equations. They build into the rest. In this case, you're going to be isolating for v. The first one is already isolated for us. The second one requires a bit of work, and I've already done it here. Then you need to equate the two velocities, and after doing the equating and simplifying, you will be presented with the fourth SUVAT equation. Alright guys, thank you for watching, and stay tuned for more content.